Hello, this is me just going over parts of the packet. If you need help completing it for the assignment, again, it's due on Wednesday. So we did 6 together on Friday. So I did 7 in class. If you were not in class or I was not in class for your class period, I'm doing this one now. So I would quickly grab an X and Y axis. And again, you can do these the other way. I'm just showing you a new way that's kind of like counting in your head. 4, 5. So if you plot G, and remember G is your center of dilation, so you always start counting from G, and then A is -2, +3. Okay, so we plot those, then we count our slope, which is always rise over run. Notice that I started at G, I went up 8, and I went right 1. It's incredibly important to always count from the center of dilation. From here, my scale factor is 2, so I multiply both of those by 2. That's going to give me 16 up, and it's going to give me 2 to the right. I add that again to G. So A prime, my image, is going to come from 16 being added to the Y value because it went up 16. So -5 plus 16 is 11. And then -3 plus 2, because I'm going right to, is -1. So that's a way to get it without counting the boxes. But again, you could just count your boxes and go up 8 and over 1 again and end up at the same spot. You don't have to do it this way. So that's how to finish everything on this. The next page requires you to write an equation. So first thing we need to remember is that the equation of a line is y equals mx plus b. M is your slope. And B, again, it's plus B. B is your y-intercept, meaning where it crosses the y-axis. So let's just quickly identify the slope and the y-intercept of the line that they've given us. The y-intercept is easy to find. You look at your y-axis, which I'm about to highlight, and see where the line crosses it. It crosses it at -4. So that's our current y-intercept. And our slope I get by just connecting 2 dots. So if I look at the next place that crosses the axes, I see it's there at 5, -5. So that's down 1, and it's right 5. So that's a slope of -1 over 5. In a dilation, the slope will always stay the same. So when you start this next part, you will always keep the same slope. So -1 over 5x. Your y-intercept will change depending on the center of dilation. In this specific instance, my center of dilation is the origin, which is 0, 0. And my scale factor is 2, so that means I'm multiplying this whole shape by 2. This is an infinite line, so it can't really get bigger, but it can move based on where the center of dilation is. So I'm just going to clean up what I already had on there. This is my center of dilation, the origin. Notice it is not on the line. When that happens, you simply multiply your y-intercept by your scale factor. So -4 times 2 is -8, and I'm done, because the distance from the center is what's changing. Doing that again really quick, again, I need my slope and my y-intercept of the given line. My y-intercept is at -1, that's where it crosses the y-axis, and my slope is looking to me like it's up 6 and over 4. So that's a +6 over 4, and that reduces to 3 over 2, but you don't have to reduce it. So again, the slope will always stay there. My center of dilation is the origin, which is not on the line. So I simply take this, I multiply it by the scale factor, and there I am. Now, in the last one, you'll notice that the center of dilation, which it's cut off on my picture here, but the center of dilation is on the line. So when that happens, you simply rewrite everything the same. So your y-intercept will say at +4 because the center of dilation is on the line. If you graph 1, 2, it's on that line. And then the slope is -2 over 1. So -2 over 1x. You just write the equation of the existing line. And then on LT4 practice, there's a few things that I want to point out. In number 2, in a lot of these, it's a lot of conceptual stuff. So you want to remember that dilations preserve parallelism. So AB is parallel to A prime B prime. And then that means that OAB is the same as OA prime B prime. This should not be anything difficult. If it is, you can always skip it and ask questions on Wednesday. This is due on Wednesday, but if you have questions, of course, that's okay. Up here on number 1, it's a scale factor of 3. I know all of you can look at 3, 4, and 5 and say 9, 12, 15. You understand that that's what times 3 is. For 4, that's absolutely fine because A, B, and A prime, B prime are the pre-image and image. What you need to be careful of is the 3 and the 5. OA is the pre-image. OA prime, not AA prime, is the image. So that means that that distance is 9, leaving 6 there. Because again, we always, always, always dilate from the center. So you can fill in all of that and finish LT4 practice. A lot of this is going to go back to just the discussions we've been having in class. But that is something that I wanted to point out. Remember, you always dilate from the center. And then we go to LT5 practice. The thing you want to remember is that scale factor is equal to the image over the pre-image. And if you do not remember, the image is always where you ended up, so the prime letters. The pre-image is where you started, the not prime letters. The first thing we're going to do is work backwards to get the center of dilation. What you need to remember is that we always dilate linearly. So I would grab a straight edge, which I know I don't have on this PowerPoint, but you should be using a straight edge, and I connected B and B prime. I wouldn't connect B and A prime because they're not an image pre-image pair. So if I connect B and B prime and then any other pair I want, let's say C and C prime, and I know where it's supposed to end up, so I'm making that happen. If you use a straight edge, it would end up there. I've now located my center. So -2, +1 is my center of dilation. Now to get my scale factor, this is where I need to focus on image over pre-image. I always start counting at the center. And then it doesn't matter if you count to B, C, or A. They'll all give you the same thing. I'm going to pick C prime just to show you that it does not matter in which direction you count, and you don't have to count in both directions. So what I mean by that is C prime to the center. If I just count the vertical distance, okay, so like the slope, just the rise part of the slope, I get 4. If I count from the center to C, and again, just the vertical distance, I get 2. 4 over 2, image over pre-image, the distance to C prime over the distance to C is 2. And I just want to quickly show you that if I did that same thing, so again, from the center, let me change it to like a highlighter, maybe that'll work. From the center, if I were to count to the right to A prime, that's a distance of 2, 4, 6, 8. And then if I were to count to the right to A, that's a distance of 4. 8 over 4 is still going to give me that 2. It's just a matter of which one I counted to. So it doesn't really matter. It will always reduce to the same thing. In letter B, I'm going to connect A to A prime to the best of my ability. Again, I know where it's going to end up, but you should be using a straight edge. And then B to B prime, there is my center of dilation at 4, 2. For scale factor, I count image over pre-image. So I'm going to start at my center, and I'm going to go to A. So A prime would be my first one to go to, so that's a distance of 2. And then A, my pre-image, would be a distance of 4. 2 over 4 would be a scale factor of 1/2. You could leave it as 2 over 4, but that's how you do that part. So that is a quick review of every last part of the packet. The rest of the packet is your homework. Have a wonderful day. I'll see you on Wednesday.